Greetings and welcome back to my Randomtronic channel. Today I will be continuing with my ring light project. Here is the PCB that we've made in the previous part. If you haven't watched it, please do so. Before we solder anything onto it, I want to try out this thing. This is the currentless tinning solution. Here is the label for it. The bottle didn't come with it. I've peeled the label off and stuck it on the bottle. I'm going to actually use this bottle for storage. But yeah, as you can see, this particular one is actually from Poland. I got it from eBay from a guy in Netherlands. But yeah, it's a Polish product. From what I saw, there are similar ones. I'm quite sure chemically it's the same thing, marked as Seno GS, part of the Seno GS system. This is meant to be dissolved in half a liter of water, so there will be quite a lot, and you can reuse it on and on and on, so it will last a very long time. Right, the instructions say that the contents of the bag has to be dissolved in half a liter of water of temperature between 80 and 90 degrees, and they recommend using distilled water or the mineralized water. What I've done, basically took water as hot as it comes from the tap in my house. I've made a little impromptu funnel out of an old envelope. So what's left is to make sure that this is dissolved, and because I've got it in a bottle, it should be easier to shake it until it fully dissolves. So I have very carefully sanded very lightly down the PCB so it's got fresh copper on it on the top. Now I'm certain that the solution has fully dissolved. I've got a phone here just to serve as a timer. We'll see how long will this take. What I'm going to do is just pour a little bit into a plastic container that I've got over here. I'm going to keep it for the purpose of tin plating, but yeah, just pour some of it, just a little bit. Right, I think I'm not gonna need the phone because it's already silver. So I'll let it sit for a while. The reaction has taken place almost instantly. Now the longer it's in here, the thicker will the cover be, up to, it claims, up to 12 micrometers. While I'm at it, I thought I've had a beaten up soldering tip, and I've cleaned it up using a drill bit and some sandpaper. No harm in trying, but I want to see if I can recoat it with some solution. 10 minutes in, that's 10 minutes for the PCB and about 5 minutes or so for the soldering tip. If that worked, I'm not too sure. Maybe I have revived it. If not, no loss. Here it is after just taking it out, and it seems the finish is very matte. It's not solder like. Let's give it a good rinse under tap water and see how it turns out. And here it is what it looks like after washing, and it's still got that matte finish, but I've just decided to touch it with a very fine sandpaper. This is 3000 wet sandpaper, and I see straight away that really nice shine is coming through, and this is what I want. So I'm just going to moist it with some water. I don't think this sanding is necessary at all. I could go straight away into soldering, but I just want to have maximum shininess on this because it's a light. There it is. That is nice. I'm happy with that. This tinning solution is quite useful, and it's really good if you're doing homemade PCBs. Tin solution, the tin on top of the copper, protects the copper from corrosion, because copper corrodes very quickly. Tin is somewhat more resistant to it, so it's good to have a coating of it. I want to use some thermal paste to make it somewhat more comfortable for the LEDs. So I've got the GD460 thermal grease. Now the LEDs have got this little pad on the bottom. This pad isn't electrically connected to either the cathode or the anode. What I want to do is I'm going to bend the legs a little bit upwards, just a tiny bit, not much, put some thermal grease underneath and solder it in while bending the legs back down, and this should give just enough pressure to firmly press the LED onto the copper. Okay, there goes nothing, so I'm going to try to film it in one shot. I may edit out a couple of long, not showing anything moments, but yeah, there we go. So I need to add a little bit of grease. place the LED. Okay, let's try to do the legs one by one, maybe that will work. Let's try to tack one of the sides. Okay, one side is tacked ugly, which is what I wanted, that's fine. So now the idea is that I can heat it up and use the leg springiness. So now I've got to repeat it 10 times and that should be done. And here it is completed. As you can see, all the LEDs are in place. I've also soldered a connector that will allow me to plug in some power to it. So let's power it up and see. Temporarily I'm using my bench power supply, so I've got it set to 25 volts at the moment, so output on, and with 25 volts it's very dim. So let's tweak the voltage. If I go lower, this is 24 volts and I'm not sure. 23 is completely out. 23 it barely starts glowing, just a little bit, and this is 24, 25, 26, 27, no 28, sorry, 29. That's 30 volts, and at 30 volts it's really bright. And if I just wait for the power supply to change, that's 150 milliamps. Need to put through about 300 milliamps or so. So I'm actually not going to push it much past 250, but let's see. If I do, that's 32 volts, and at 32 volts, 31 volts actually, it's 250 milliamps, and this is really bright. I quite like this. At a small distance this will make a huge difference to the camera, and the light is even because those LEDs are quite nicely dispersing the light. They're not focus point type of LEDs, they're very wide angle. To power this permanently I'm going to use this, a boost converter. Slight change of plans. So I was going to power this up with a boost converter, which turned out to be a buck converter, and that's not going to work clearly. So I found a different boost converter that actually is a boost converter, but this one goes only up to 25 volts ish also, or 28 volts, which is not enough to power this up. So I have to do with what I have on hand. So I'm going to, instead of having all the LEDs in series, I'm going to split it over here, so right in the middle, and make it two series of 5 in parallel, like this. And this should solve my problem of absent voltage. So now I can get this connected. I'm going to put a small resistor, I think this is like 1.6 ohms, just for good measure on the on one of the power lines to this. There we go. So this is working out quite okay. So I've got this connected to bench power supply, 5 volts. I want to set it at maybe half an amp, so that will be double of what a single string of LED would draw. Okay, so now I'm on a USB cable, 1.8, 1.9 amps at 5 volts from USB, and this converter is getting toasty. And also I'm not getting the full half an amp from this right now. Okay, here it is running with half an amp going through LEDs, and now I've put 12 volts on the input, and the converter is running much cooler. Before it was getting really hot. So I think I'm going to settle for this. I've got 12 volt power bricks available, so that could work. Of course this whole nonsense would not be happening if I had the right boost converter. And there it is, complete. Now I'm running a stress test on this to see how hot will it get, and I've had it on, I've set the boost converter to 0.5 amp, and this boost converter is just barely warm. This is quite warm, but no drama at all. It might be maybe 40, 50, maybe 60 degrees maximum. It's stable at this temperature, it's not rising anymore. So at 0.5 amp, putting out actually an insane amount of light. When I look directly on it, it hurts. What's left to do is attach the ring adapter to it. I'll do that later on off the camera. I'll probably just use some epoxy and just epoxy it in place this way, or from underneath like this. Then we're going to test it and see what sort of improvements will it make on the image. But for this video I think that's it, so thank you very much for watching. That was part 2. Hope you enjoyed it. Please do subscribe for more random electronics related stuff, and for the time being, take care.